How many of you ever wondered what is a QR code? How many of you ever wondered how a QR code actually works? It's just a sticker there. QR code itself has quite a few modules that we need to be aware of. You can see the small box inside the QR code, which is called the alignment box. What is the use of this alignment box? When you have this QR code scanned from straight, left, right, up, down, inverted, whatever direction you have your camera and scan in, how does your application able to identify the QR code and understand the direction how the QR code is? When you have a QR code and assume the QR code is damaged on a particular portion, have you noticed even in such scenarios when you scan the QR codes, it still scans? How does that even work when it's damaged? Let me quickly talk about the history of QR code before I actually start talking about it. So we are all aware about the one-dimensional barcode that we used to have. The one-dimensional barcode as in the vertical lines. So we all used to scan codes like those one-dimensional lines. But as a natural progression, we all moved from those one-dimensional lines to a two-dimensional figure, which is the barcode. Barcode actually is the QR code that I'm talking about. So it is a two-dimensional barcode. This two-dimensional barcode has both horizontal and vertical. So when I say horizontal and vertical, both horizontal and vertical contributes to the data which could be stored onto this barcode. Talking a little about the history of these QR codes, this QR code was developed by a Japanese company called Denso Wave, which is also a subsidiary of Toyota. They developed this code specially for tracking manufacturing items that were getting developed in their factories. So it is as similar as this. US developed ARPANET, and from ARPANET we created the internet, which got to the public's hand because of the benefits that they were able to see. Likewise, this QR code which was used internally inside the factories of Japan was then made public considering the benefits that it could bring to the public. Okay, talking about QR code itself, right? QR code itself has quite a few modules that we need to be aware of. Number one, you need to understand the alignment box as a part of QR code. You need to understand what is a data module, and you also need to know what is a finder pattern. If you know what is a finder pattern, if you pay attention to a QR code, it is those three boxes which you could find on the three edges of the barcode, on either three of the corners, where it would typically say what is the encoding used in the QR code and what is the length of the QR code, what is the character set that used in the QR code. For information, a QR code can actually hold data sets or character sets such as binary, hexadecimal, decimal, and also interestingly kanji. Kanji means a Chinese character form, which is almost similar to our ISO and Latin type forms. Okay, talking about the next alignment box. You can see the small box inside the QR code, which is called the alignment box. What is the use of this alignment box? When you have this QR code scanned from straight, left, right, up, down, inverted, whatever direction you have your camera and scan in, how does your application able to identify the QR code and understand the direction how the QR code is using the alignment box? And then we are talking about the data module. Data module is very interesting. It is almost similar to the old brick video games that we used to play in our childhood. It is almost similar. It's built like that. Every single brick block actually is used to fill in the particular data module space, encoding with the data in it. And the interesting part is it also has something called redundancy data, which is a part of their checksum error. Okay, let me talk about the data module. So what happens is the data module can hold close to 4,296 characters as a part of the QR code. So it can be of any data or character set that I mentioned, number one. Number two, when you have this QR code, redundancy block or the redundancy block. So what happens is when you have a QR code and assume the QR code is damaged on a particular portion. Have you noticed even in such scenarios, when you scan the QR codes, it still scans? How does that even work when it's damaged? Right? So what happens is they have something called the cyclic redundancy check, which is otherwise called the CRC checksum, which is a part of the data module itself, where they have the redundancy check. So a portion of the data is scattered in multiple places on the same QR code also, right? So it makes it really interesting. And this whole QR code idea was derived from the old Chinese game called the Go, which has both black and white pebbles to play. And taking it one step forward, a very interesting stats that I want to share here is number one. In 2022, in India alone, UPI transaction had close to 70 74 billion transactions in the whole year, accumulating close to around 129 trillion INR value. This is in 2022. In 2023, the 74 billion scans were approximately 84 billion, close to 10 billion scans improved. And the value of the whole transaction is close to around 140 trillion. I hope you all had something to learn from this particular video. In case you did, please consider a like and a subscribe. Thank you.